Good morning, guys.
Good morning.
Good morning.
Good morning.
Good morning.
Morning, Jeff.
Morning.
Morning, Savannah. Okay, guys. Okay. So the other day we finished off at what we call the pH scale. So let's just try to get back to that one as well. Before we go there, we can make it okay. What was pH? So pH is going to be the negative logarithm of, the hydrogen ion. Now this is important, okay? It's going to be the hydrogen ion, which is positive concentration. Now what we did was we had a scale. Okay, so we actually have something that we call is pH scale, which goes from 1 to 14. Yeah, okay. And if you find this, okay, let's just drop the scale. The highest pH is 14. The lowest pH is 1. And what we said was that for us here is okay, we will take is okay 7.4. That is going to be is okay what we'll call a neutral pH. Okay, which mainly will mean that okay, yes, it's not acidic and it is not alkaline. Now, guys, on a scale, as we go from 7 or 7.4 towards 1. Okay, so we can say is okay if we go in this direction here. That's going to make a substance be more acidic. And since it is going to be more acidic, that will mainly, on the other hand, also mean that it's going to be less alkaline or basic. Whereas on the other hand, if we compare the pHs from 1, 2, 3, 4, 5, as we go in this direction here, is going to become, we can say, okay, less acidic. And if something is okay, is going to be less acidic, is going to become considered to be more alkaline. Okay, but a pH less than 7 or 7.4 in this case here mainly will mean that, okay, as a medium is going to be acidic. Okay, of for instance, okay, comparing as okay the pH, let's say is okay 5 versus 2. 2 is more acidic compared to, yes, okay, we had something with a pH of 5. It's going to be less acidic. And a substance which is less acidic is going to be more alkaline, or a substance which is more acidic is going to be less alkaline. Whereas on this side of our scale here, generally speaking, yes, okay, these will all be alkaline pHs. So yes, okay, as we go in this direction here, from let's say it's okay 7.4 to 8, 9, 10, 11, 12, 13, and 14. Okay, yes, okay, it's going to become more alkaline or basic, and which mainly will mean that it will be less acidic. Or on the other hand, if you go from, yes, okay, from an extreme acidic or alkaline, sorry, environment or medium, okay, or the pH value actually decreases, it's going to become less alkaline. And if it's less alkaline, it means, yes, okay, will be more acidic. So when you talk of, okay, as a pH number on the scale, okay, for instance, okay, 1 is extreme acidic. Okay, we can, for instance, also say, it's okay, we had a pH of, let's say, 5. This is still going to be as okay acidic because it still falls on this side of the pH scale. Okay, but as far as, okay, its acidity is concerned, it's going to be as okay compared to 5 or 1, sorry, or pH of 1 is going to be less acidic. Okay, if you take, for instance, okay, a pH of 6, okay, then okay, that we can say, okay, compared to, yes, okay, these 3 pH values here, yes, okay, is going to be, yes, okay, the least acidic one. Now, once we cross the neutral line or the neutral value, now we are going to be on the alkaline side. So even as, okay, on the alkaline side, we can say, okay, if we, for instance, okay, set a pH of 8, now this is going to be as, okay, where we have a say, just give me a second. Sorry, guys. So if for instance, okay, a pH of 8, well, okay, we can say here this is going to be least alkaline compared to, yes, okay, we said a pH of, let's say 10. That's going to be, yes, okay, more alkaline than 8. Or if you go to and say, yes, okay, what about a pH of 13? Well, okay, in these three readings here, okay, this is going to be the most alkaline. Right. So the pH scale is mainly, yes, okay, just a scale can extend from 1 to 14 with a neutral value, that's okay, around 7.4. Okay. The reason we use 7.4 is because that is the neutral pH of blood. Okay. Or you can say, it's okay, now here comes the thing. When we say, it's okay, the negative log, which mainly will mean that okay, let's do this way. The lower the hydrogen ion concentration, that's okay, greater will be your pH because of the word negative. Whereas if you go with the other way and say that the higher your hydrogen ion concentration, that's okay, the lower your pH.
Does that say negative together?
Yes, negative is one word, my dear.
Thanks.
Can you repeat that one more time, please?
Let's put it this way. The greater your hydrogen ion concentration. If we have a greater hydrogen ion concentration, we will have a lower pH. That makes sense. So mainly as okay, a substance with okay as a high hydrogen concentration. For instance, okay, hydrochloric acid has a low pH value. Its pH is going to be 1. Whereas on the other hand, where we say it's okay, a high pH value, if you have a high pH value, that is mainly because we have a low hydrogen ion concentration. Okay, and what did we need it for an acid? An acid mainly is okay was a hydrogen ion. Okay, and in this case, it's okay, mean it's combined with any other anion, but that makes an acid. So the higher the hydrogen ion concentration is going to be as okay, the lower the pH. And vice versa.
Can I just, oh, sorry. After that word negative, what does that say? Does it say log something?
Logarithm.
Logarithm?
Yeah, or
Okay.
if you don't want to say logarithm, you can just say log. That's fine too. So negative log of the hydrogen ion concentration. Okay. But what that mainly would just mean, guys, is, let's put it this way. The higher hydrogen ion concentration. And that's making us okay because we said that the pH was okay as a negative log. Okay. That's how that's okay. A high hydrogen ion concentration will lead to a low pH. Where on the other side, or on the other end, we can say is okay, a low hydrogen ion concentration mainly will cause that okay as the pH number is going to be great. And what this will lead to is it will make a substance more acidic, or on the other hand, yes, okay, less alkaline. Whereas on the other hand, when we say it's okay, a low hydrogen ion concentration, where have okay as a great pH. And what is that great pH is going to mean? That okay, something is going to be, you can say it's okay, less acidic. And when something is less acidic, it's going to be as okay more alkaline. And what do we mean by this? That's okay arrow here. An arrow here is mainly as okay just the number on the scale. So that's okay. A smaller number on the scale is this. A greater number on the scale is this. In between the two, yes, okay, we have a neutral value. And what does it mean to be neutral? Neither acidic, neither alkaline. I'm not on one team, I'm not on another team. Did that make sense? Okay. So mainly because the definition says negative log. What that negative log means that the greater the number, in this case, it's okay, the lower is going to be a hydrogen ion concentration. So when you have a greater pH value, you have a lower hydrogen ion concentration in that medium or molecule. Okay. And mainly because, okay, the hydrogen ion was the must ingredient for an acid. Did that make sense? Okay. So lesser hydrogen ions will cause that you have a greater pH scale, a greater number on the pH scale of that medium or molecule. Okay, so the greater the pH number or value, lower will be the hydrogen ion concentration. Whereas if you say, okay, I have a lesser value on the pH scale, that will mainly mean that we have a greater hydrogen ion concentration. And the greater the hydrogen ion concentration in a molecule, more acidic is it that it will be. Because that hydrogen ion was the main component necessary for the, you can say it's okay, composition of a acid. Did you guys get that?
This may be a little off topic, but did you
No.
say there was a difference between a compound and a molecule?
No, there's no.
Okay.
Because
I wrote the
what's a molecule? It's mainly as okay, two or more than two atoms coming together. Okay. Okay. Now that may go under either the word compound or molecule. Because what is it that the word compound actually means? Taking things, putting them together to create a new thing. Okay. So when you, for instance, okay, are let's say it's okay making a cake. That cake becomes a compound. Well, let's not take it to the finished cake yet. Just you is okay taking, let's say, eggs, milk, sugar, flour, flavoring agent, etc., and putting those things together. That is compounding. Okay, but what do you get at the other end? Okay, you get a batter. And then you make it, okay, bake that batter, and okay, as you make it, bread, cake, cookie, whatever. But pretty much, okay, putting those things together to make a new product is compounding. So here it's okay, we can say it's okay, we take different atoms, elements, and put them together, and what do we get? We get a new product. Okay, so that product can be called a compound, or you can call it a molecule. Did that make sense?
yes.
Okay, any questions about the pH or the pH scale?
I just have a question about next week's quiz.
Huh?
Is it for next week's quiz? Is it only
Yes,
going to
madam.
be chapter 3, 4, 5, or is this going to be on the quiz as well?
Well, my dear, for your next question is going to be, it's okay, the last two chapters that we did in medical term.
Okay.
And probably it's okay, the first 2 or 3 chapters of this book here.
Okay. Thank you.
No problem. So guys, just keep in mind, the greater your pH value, lower is the hydrogen ion concentration. And the lower the hydrogen ion concentration, less acidic is it that a substance is. Now, if a substance is less acidic, it's going to be more alkaline. Okay. Whereas if you go on the other hand and say a lower pH value, that will mainly mean that you have a greater hydrogen ion concentration. And the greater your hydrogen ion concentration, more acidic is it that a molecule or compound or media is going to be. Okay. Now we ideally want the blood to have a neutral pH. Okay. Ideally speaking, yes, okay, your blood should have a neutral pH. Okay. Now there are some areas in the body which by nature will have an acidic pH. Your stomach, for instance. The internal environment of your stomach is acidic, which mainly means, okay, that the contents of your stomach is going to have, okay, as an extreme low pH. Finally, what causes that low pH in your stomach is because your stomach produced acid called hydrochloric acid. Okay, so that's what leads to things such as heartburn and all that. Okay, but we talk more about that in your digestive system. Okay. ideally speaking, well, okay, not extreme alkaline, but if you talk of urine, you want it to be a little bit more on the alkaline side than, no, sorry, acidic side than the alkaline as well. Okay. But yes, okay, the rest of you, yes, okay, gut beyond your stomach is not going to be on the acidic, but rather on the, or have a pH on an alkaline side. Okay, as far as blood is concerned, we do not want that to be either acidic or alkaline. Okay. So if they check a blood specimen and you have a very low pH, or the pH of your blood is low, that will be as okay, what they will call acidosis. Or on the other side, if they check your pH of the blood and find it okay as that you have a high pH, that's going to be what they call alkalosis. Now there can be different reasons for acidosis and alkalosis. Okay. Okay, guys. Any questions? So let us just talk a bit about, yes, okay, what we can call the yes, okay. We can call it compounds, or as we say, yes, okay, they can be referred to as molecules. But here is okay, intentionally it's okay, we will just use the word compound. And or as okay, molecules, which mean it's okay, say that okay, as when two, or let's say it's okay, more than two. What does more than two means? Well, okay, it could be 20. It could be 120. It could be as okay, 1200. It could be as okay, 1000, 1, or 11,200. Like that. Okay, so that's probably as okay, no upper limit of yes, okay, how many elements. And that's why it says okay, to make it a compound, yes, okay, they will be joined together. So these different elements, X, Y, Z, number of them, when they join or bind themselves or bind with one another, that new product is going to be as okay, what we'll call a compound. Clear? Okay, what holds these elements in the compound together is going to be as okay, bonds. Okay, and what do we call these bonds? Simply as okay, we can call them chemical bonds. Okay. Now there is okay as a bigger classification of okay as chemical bonds, because these chemical bonds here is okay actually due to, you can say it's okay, electricity of the different elements or energy, or is it because of okay as what we call a valency that causes okay elements just okay bound to one another. Okay, but simply as okay, not to go without going into all those details, we can maybe as okay just say that, or maybe as okay hold these elements here together, and we can roughly call them chemical bonds. Okay, And what may happen to these chemical bonds is that, okay, yes, they may break. Okay, and what that happens, that's okay, that's where it's okay, these, let's say it's okay, different elements that we had in our compound now are going to be free birds. Okay, now some of these elements may, it's okay, just join with elements from another compound to form new compounds. Did that make sense? Okay, I'll just put it this way. Let's say all of you were classmates in kindergarten. Let's just take that example. Now, after kindergarten, yes, okay, some of you might have moved to another school because you moved to a different town. Okay, so you guys as a classmates, that's okay. In kindergarten, that was one compound because you were brought together in one class. Pre-K1. Did that make sense? Now, some of you, yes, okay, went loose. Some of you, although it's okay being in the same school, but it's okay, we'll go to class 1A, some of you go to 1C, some of you go to 1B, some of you to 1D, or first grade 1BD. Some of you may move to other schools. There, what do you do there? You make new bonds with your new classmates, right? Okay. Some of those classmates that you made a bond with, yes, okay, might move on. They may come back to yes, okay, to your old school, yes, okay, where you were pre-K classmates now are in second grade, for instance, and make a bond with that. So that's okay, bonds are made, bonds are broken, just so that new bonds can be formed. And as new bonds are formed between, yes, okay, different elements, it becomes, yes, okay, a new compound or a new molecule. Did that make sense? So that's pretty much okay. Yes, well, okay, pretty much. An easy way of talking is okay. How is it that okay? Yes, the chemical factory in the body, yes, okay, runs. Now, when we talk of compounds or molecules, or as okay, in terms of chemistry, we can mean this as okay that we have two major types of compounds. Okay. But what we also can mean by compound is just as okay, can also be as okay molecule. One is going to be as okay, what we will call inorganic compounds or molecules. Okay. And chemically speaking, yes, okay, what are these going to be? Yes, okay, these are going to be yes, okay, simple. And saying yes, okay, because they're simple, that's because it's okay that these are small molecules. Okay. Now, what we mainly mean by as okay, them being small or simple is that it's going to be as okay, being as okay, a low number of elements that makes up these molecules. Whereas on the other hand, guys, other kind of compounds or molecules that we have are going to be as okay, what we can call as okay, organic compounds. Okay, and organic compounds are just going to be the opposite of your inorganic compounds, which are going to be SOK complex in their chemical structure. And why is it that they're complex? Mainly SOK because that they are large. What does that mean? Okay, is to be large or complex. That means SOK going to be SOK that is going to be SOK a great number of elements in a compound. Now, guys, if you for instance, okay, take inorganic compounds, just to take a few examples. Water, yes, okay, that's an inorganic compound or molecule. So H2O, okay, that's just the chemical formula of water. We can take another one, sodium chloride. Okay, now mainly that's okay, what we plain words just for refer to as salt. We can even say as okay, something like okay, HCl. Now, I mentioned that the other day, that's what you call is okay, hydrochloric acid. For mainly it's okay, very simple. It doesn't need a lot of okay as elements, just hydrogen and chloride. You can even say as okay, something like okay, sodium hydroxide. Because okay, what we need is a sodium atom or element and okay as a hydroxide ion. Okay, so relatively as okay, small molecules. Okay, which have okay as a simple chemical structure. Just if, for instance, look at water, it's one O with two hydrogen ions. That's the chemical structure of a water molecule. If you look into yes, okay, books or texts of chemistry, for instance, what is that you may see as okay, a bigger or longer yes, okay, chain of yes, okay, where that's okay, maybe yes, okay. Where's this okay? And it can go on and on and on. Okay. So something like this is probably not going to be as okay or organic, inorganic compound, but rather is going to be as okay become an organic compound. So yes, okay, whether that is drugs, whether that is whatsoever, yes, okay, everything is okay will have a chemical structure. But if it's something like as simple like these, that's going to be as okay inorganic compounds. And with the Emilius, okay, study all about yes, okay, inorganic compounds. That's what you call inorganic chemistry. You study more complex molecules like proteins, starch, fats, very complex acids, and so on. So, or alkalines, that will be yes, okay, organic chemistry. Okay, but here we're not taking a chemistry class. We're not going to be focusing upon chemistry in that much detail. Okay. So just remember, simple small molecules, or you also can call compounds, will be referred to as inorganic compounds. The large, complex molecules or compounds will be organic compounds. Okay. Just some few small examples of as inorganic compounds: water, H2O, salt, sodium chloride, hydrochloric acid, potassium hydroxide, sodium hydroxide, even such as ammonia, NH4 is the chemical formula for ammonia. Not pneumonia, ammonia. Okay, so those are relatively small molecules, simple chemical formula or structures. Whereas when we talk about the organics, organic compounds, they're going to be huge. They're going to be relatively larger compounds. Okay, now what would it mean to be larger? Mainly as because they are made of a greater number of elements. Okay. Any questions? Okay, guys. Just a little about our okay, just a little bit about our organic compounds. So guys, when we talk organic compounds, now we can mainly say we're going to have 4 subtypes of organic compounds. Now the first one is going to be what we can call carbohydrates. Is that clear? And carbohydrates is what we mainly in common words may refer to as sugars. Did you guys get that? Okay. Now please keep in mind, guys, that sugar does not necessarily have to be sweet. Usually it's when we think sugar or when we say sugar, you may think, this has to be sweet. They're actually going to be sugars which are not sweet. They may not necessarily be bitter, but they are not sweet. Okay. But we mainly call them carbohydrates. Now, why do we call them carbohydrates? Mainly because these molecules here are going to be made up of carbon, hydrogen, and oxygen. So a molecule which is made up of carbon, hydrogen, and oxygen makes what you call becomes what you call a carbohydrate. Okay, which we can call a sugar. Okay. Now, just to talk, yes, what is the primary purpose of carbohydrates or sugars in the body? Well, being an organic compound, while these are primarily for the body, is going to be, we can say, the primary source of energy. Some people may say, okay, the word energy can also, okay, be replaced by fuel. If you just think of, okay, as gas in your car. So your car runs on gas, which is going to be the source of energy or the fuel that's going to make that engine run. So for your body, the primary source of energy is going to be carbohydrates, also known as sugars. Okay. Now, guys, usually it's okay when we talk sugars. Okay. We may not use the word carbohydrate. We may not use the word sugar. We may, it's okay, use a term that we call glucose. Because, okay, as the body primary source of fuel, which is going to be a carbohydrate or which is going to be, it's okay, a sugar, will be glucose. Okay. But this glucose here is okay, what it is it's going to be? It's still going to, yes, okay, we call it a carbohydrate mainly because it is made up of carbon, hydrogen, and oxygen being brought together. So chemically speaking, yes, okay, we can say the chemical formula for the molecule glucose is going to be that has 6 carbons, 12 hydrogens, and 6 oxygens. This is the straight chemical formula for the sugar or carbohydrate known as glucose. Okay. Now, how would we know that a substance is a sugar? Or as a matter of fact, a carbohydrate? That is determined by the ending phrase "ose." So we can mainly say, okay, any substance that ends with "ose" is going to be sugar, or is going to be, as okay, a carbohydrate. So just some other examples of carbohydrates or sugars will be things such as lactose. We have something called maltose. We have something called, okay, let me just bring it over here. Fructose. We may even have as, okay, something called cellulose. But mainly as, okay, what is it? What we see in all these here is, okay, they end with the word ose, ose, ose. And that's pretty much, okay, as what makes them sugars or carbohydrates. Did you guys get that? Any questions so far? Any questions? Okay. Well, what we mainly can say here is, okay, out of all these sugars, the primary source of energy that your body will need is going to be glucose. So whatever glucose your body produces from this, okay, breakdown of bigger molecules of sugars is going to be the primary source of energy that your body will use. That's why it's okay if your glucose level runs down, you are low energy. Did that make sense? Good. Now, guys, let's just take one example here. Now, if we just look at the word lactose here. Now, what we say is, okay, lactose is mainly, it's okay, the sugar of what you call lact. And the word lact actually is okay, means milk. Okay. Now, this sugar here, or lactose, chemically is okay, or as okay as far as its chemical structure is concerned, is going to be as okay what we'll call a bisaccharide, where the word bi stands for chew. And the word saccharide here is made as okay, again, just a fancy word that just means sugar. So what actually happens when this lactose molecule here is broken up, what it will release is going to be two different sugars. One is going to be as okay what you call glucose that we just see here. And the other sugar that's going to come from the breakdown of lactose, which is a bisaccharide. Why is it a bisaccharide? Meaning because it's made up of two sugars that's going to be as okay. Another sugar released, which will be what we'll call lactose. And what are these two here going to be? Both of these sugars, yes, okay, they're still sugars, they're still carbohydrates, but they will, okay, chemically be referred to as being monosaccharides. So glucose is a monosaccharide. Galactose is a monosaccharide. Did you guys get that? So lactose mainly, yes, okay, was a bisaccharide because it was a sugar, which mainly is okay, were made up of two different sugars. Or we can say, okay, two molecules of sugars. You may come across a word which is going to be as okay, what we may call polysaccharides. Maybe again, it's okay, just can say that okay, as the word saccharide. It still is okay, just the term that okay as refers to sugars. And poly In this case, is okay. Not 2, not 3, but many. And a molecule which is okay will be considered as being a polysaccharide is going to be as okay what we can call starch. Okay. But when starch is broken up, pretty much okay as chemically, what is it that it will do? It will release a lot of glucose molecules. Pure glucose. So literally as okay, what is it that we can say that a starch is going to be? It's just going to be as okay, a lot of glucose molecules bound together. So when the starch is broken up, what will it do? It will release a lot of glucose. Did you guys get that? Okay. So an example of polysaccharide will be starch. Not because it has, okay, has a great variety of glucose, of, okay, carbohydrates or sugars, but mainly because it's a molecule which is built up of a lot of glucose molecules held together. Okay, so things which are rich in starch as a molecule, it's going to be rich in glucose. Because when that starch is broken up, what is it going to do? Release a lot of glucose. Okay. But what is it that glucose is going to be used as? It's going to be used as the primary source of energy for the body. Any questions yet? Nope. Now, guys, now, although we say it's okay that it is the primary source of energy, but the question may just arise, how much energy is it that, okay, as carbohydrates supply us with? So we can mainly say that, okay, that's 1 gram of carbohydrates gives up to 4 calories of energy. So roughly speaking, it's okay, 1 gram of carbohydrate. That reaches the bloodstream, yes, okay, will provide us with 4 calories of energy.
Sorry,
No.
I'm just sorry. On that last slide, I was a little confused. The glucose, the C6H12 and O6, what
Yeah.
were those numbers again? Like,
Don't worry about that, man. It's just going to be, okay, how many atoms of carbon, how many atoms of hydrogen, and how many atoms of oxygen do you have in one glucose molecule?
okay, thank you.
Okay, so it made us, okay, becomes like, okay, yes, if we then just, okay, want to draw the molecule structure of a glucose molecule, you say, okay, as we have, let's say, it's okay, that's okay, well, it's okay, there's 6 carbons, and then we have, it's okay, 2 H's and 1 O to each of them, or something like that. But that becomes, yes, okay, you can say the chemical structure of a glucose molecule. Yeah, okay. But there are going to be, yes, okay, some sugars which will go into, okay, different number of carbons, different number of hydrogen, and different number of oxygen in that carbohydrate molecule, which just will make them as, okay, a different type of sugar. Did you get that deal?
Yes.
Okay. But generally, it's okay, even as, okay, if you take any sugar molecule and break it down, these are going to be, okay, the 3 types of atoms or elements that's going to come out of it. And that's pretty much, okay, why we call them carbohydrates, because they're mainly made up of carbon, hydrogen, and oxygen. Now, guys, you can say, okay, or next, what you want to call this, okay, organic compound is lipids. Or let's say, okay, let's use a common word, fat. Okay. Now this fat here is, okay, we may find it in different forms. That's going to be as, okay. Or in the next chapter is, okay, we'll refer to as phospholipids. Or as, okay, where the word lipid itself is simply as, okay, your fats. What we also may find is that, okay, as some of our hormones are going to be as, okay, derived from fat. Okay, so those hormones which are derived from fat, that's okay, can also be as, okay, what we will call steroids. You may have heard the word steroid again and again and again and again. But what is it that steroids mainly are? Okay. Either hormones, that's okay, which are derived from fat, or you as, okay, chemical substances produced by the body which are fatty in nature. Can be referred to as being a steroid. Did you guys get that? And then we just have, okay, as we can say, okay, fat, as that says, okay, an adipose tissue. Now, as far as the phospholipids is concerned, yes, okay, we can say, okay, that's going to, it may sound strange, but it's going to be, yes, okay, in bodybuilding. Not really bodybuilding like okay, Arnold Schwarzenegger, but actually, yes, okay, say, yes, okay, the building up of your body cells will need phospholipids, which chemically is a form of fat. Now, for your body to, yes, okay, make some hormones, they may need fat. Even for your body to, yes, okay, make up substances, just called steroids because, yes, okay, they are derived from fats. Some of your hormones are going to be steroidal hormones because they are derived from fat. Okay. But you, yes, okay, you can say, okay, even the adipose tissue that accumulates in your body, okay, is primarily, yes, okay, going to be fat. So what is going to be, as okay, basically, as okay, what is going to be our main functions of fat? Primarily, guys, it is what you can say is okay, an energy storage. Now, it may sound strange, but out of all the sugars that you consume, you may not utilize all of it right now. So the sugar that you don't use right now may be stored by your body. Primarily as okay, what we call glycogen, which is thus the name for stored glucose. But over the time, yes, okay, that glucose may be chemically get converted into fat that your body may, yes, okay, just store as a source of energy or storage for, yes, okay, energy if your body runs low on glucose. It may, yes, okay, going to reconvert that fat back into glucose and use it as a source of energy. But if you keep on, as okay, consuming energy or glucose, and don't burn out, more and more and more is going to be stored and become fat. Clear? Okay. And that's where it's okay, the waist size starts to increase. Okay. Okay, guys. That's not everything that is bad about it because it's okay. It is also it's okay. Beside me, it's okay. Depot of energy. That's okay. It's also going to act as okay as far as okay what you can call insulation. Okay. Now the primary reason for insulation is mainly as okay to ensure that whatever energy your body produces, primarily as okay, let's say it's okay the form of heat, that your body doesn't indiscriminately lose that energy. Because then your body is going to be cold all the time. So mainly it's okay, whatever heat energy your body produces. Okay. Is yes, okay, your body is okay, will be able to retain as much energy as possible because that the fat or the adipose tissue actually acts as an insulation. That's why nowadays, that's okay, people are that's okay thinking of okay as energy efficient windows and things like that. Okay. Otherwise, it's okay, you can have yes, okay, your heater blowing on 24/7, just using yes, okay, a lot of okay as gas to warm up the house. But if the insulation of your house is poor, it's okay, all that heat that is being produced very much okay as leaves through the windows, which may not be well insulated. So what happens? Well, okay, as Santa or Petro or whoever is okay, deliver your gas for your heating in your house, that's okay. They're going to be happy, but not you. Because that's okay. That's a lot of money, that's okay, coming out of your POCAETs. So likewise, as okay, the body is also going to be as okay insulated so that you don't, please, I said, indiscriminately lose the heat that you produce, which you produce as you burn primarily glucose. Did that make sense? Good. Now, in some instances, or rare instances, okay, this fat here is okay. Now, maybe a storage of energy, yes, okay, storage of energy, yes, okay, energy that is stored that you didn't use as it was, you can say, consumed by the body. Okay. But at large, that's okay, it may be, yes, okay, it may be still a source of energy. And when we talk about fat being, yes, okay, a source of energy, yes, okay, that gives up to, yes, okay, we can say, okay, 1 gram of fat gives you, yes, okay, up to 9 calories of energy.
Does that say building cell under the
Yeah,
fossil?
exactly.
Okay.
Now we're going to talk more about that in, yes, okay, your next chapter. By you, yes, okay, we just, yes, okay, or remaining can say, yes, okay, in a phospholipid. This word here is okay, refers to fats. Now, please keep in mind, guys, fats is not going to be the primary source of energy. Okay, fat is not going to be the primary source of energy. It's only if your body, for instance, okay, is running low on glucose that it may take from, yes, okay, from the energy storage, convert that fat into glucose again, and use that as a source of energy. Well, as far as the calorie value of fat is twice that of sugar. And that's mainly, it's okay, you say it's okay. It takes more, it will take twice the workout to burn 1 gram of fat compared to, it's okay, burning 1 gram of sugar.
So it's easier to burn fat. I mean,
No.
it's harder to burn fat than carbs.
Yes. Just think of, okay, as if you go to the gym, you say, okay, my goal is to burn this many calories. Now, since that's okay, sugar has half the calorie value than that of fat. Okay, so you want to say, it's okay, I want to burn 1 gram of sugar. That's okay, it's going to need half the workout. Or it's okay, you're burning half the calories that you have to do to, it's okay, burn 1 gram of fat. So that's why it's okay, fat may, it's okay, become, it's okay, a stubborn molecule, it's okay, get rid of. Okay, guys. Now, probably it's okay, the most versatile inorganic compound is proteins. Or you ask, okay, we talk about the molecules or compound molecules. Oh, sorry. Organic molecules, we can say, it's okay, the protein that they are going to be the most complex organic molecules. Now, what we mean is, okay, why is it that we call them as, okay, the most complex is because they are going to be the largest organic molecules. Now, simply as, okay, just if we just want, just, okay, say, if you take a protein, any type of protein, what is it that this protein here is going to be made up of? It's made as, okay, going to be made up of molecules themselves known as amino acids. So a protein made is, okay, just going to be, as, okay, a long chain of amino acids. Did you guys get that? Now let's just say that, okay, as we have an amino acid. Let's say it's okay, we have an amino acid. And let's say it's okay, we have an amino acid. And please, that's okay, these amino acids themselves are molecules. Okay. Now you're probably not going to have a protein which is made up of just, okay, just 3 amino acids, but here just okay, make it simple. Because these amino acids here, okay, are going to be bound together by bonds. Right. And this bond here is okay, although it's okay, on a large, we could call them as, okay, chemical bonds. But this specific bond, I mean, is okay, holds 2 amino acids together, is going to be as, okay, what we'll call a peptide bond. So what is going to be as, okay, what we'll call a peptide bond is what bonds or holds, let's say it's okay, 2 amino acids together. Did you guys get that? Now we actually, that's okay, may have proteins. If we look at, okay, the structure of proteins, some proteins may have up to, yes, okay, 2,000 amino acids being held together. Now, just the same example as I said earlier, that, okay, yes, this protein here, well, let's say, as okay, let's just say that there was 2,000 amino acids. When these peptide bonds here, it's okay, are broken, what is going to happen? 2,000 molecules of amino acids will be released. Now again, yes, okay, some of these amino acids may, yes, okay, make bonds with other amino acids coming from other proteins to just make new proteins. Did you guys get that? But the basic building block of an amino acid is going, of a protein is going to be what you call an amino acid. Okay, let's not go into, yes, okay, the types and so on. So the variety of amino acids is pretty less small. It's okay, they're not that great. It's 26 different amino acids. That's the total. But it's just a matter of, okay, as the sequence in which they are bound together that makes us, okay, proteins become different. Or you can say, okay, the structure of that protein become different. But even as, okay, if that is broken down, what it will do is release those individual amino acids, which may, as okay, form new bonds with other amino acids from other proteins. And now you have a new protein molecule. So, Lasha, go. Go. Okay, yeah, you're doctor. Good job. Okay, sorry. Did you guys get that? Okay, so just think of, okay, as a protein is, okay, as a long chain of, let's say it's, okay, bricks. Well, that's okay, as far, let's say, the color of the bricks that you have, there's only, it's okay, 26 colors. Okay. But when you break that wall down, you will have 2,000 different bricks being released. Now, some of those bricks, that's okay, may join together, join with bricks from other walls, and you form a new wall. Okay. Which may, is okay, due to the composition of the colors and so on and so on. So put into that, yes, okay, make a new design. Or may appear different. Okay. Now, the reason that I said that, that's okay, protein is the most versatile of our organic compounds is mainly as okay because chemically speaking, that's okay, we call them proteins. But as okay, function wise, that's okay, these proteins here, as okay, may have a greater variety of functions compared to as okay, other organic molecules. So, okay, let's put it this way. We just so what are going to be as okay, some of the major functions of your proteins. Now, primarily, guys, Well, okay, we can say, okay, your muscle mass. Your muscles. Chemically, yes, okay, are made up of proteins. So, yes, okay, since they make up your muscle, yes, okay, that's where they become, yes, okay, actually, yes, okay, bodybuilding. Another thing is, a lot of these proteins, yes, okay, will act as substances that we call enzymes. So we may come across a word that is going to be as okay, enzyme. Okay, now just to bring it here, it's okay, what is that an enzyme is going to be? It's going to be as okay, a chemical substance. Okay, an enzyme is going to be a chemical substance that, now I may use a word here, catalyzes a chemical reaction. And what we mean is, okay, just mean by catalyzer is going to be a primary, yes, okay, B speeds up. Or we can say it's okay, facilitate a chemical action to be carried out. So a lot of chemical reactions in your body can only be possible due to, yes, okay, the presence of enzymes. Okay, which are chemical substances, but chemically, yes, okay, they are going to be proteins. Functionally, yes, okay, they're going to be substances that, okay, speeds up or, yes, okay, facilitates a chemical reaction. And I will just give a short example of, okay, as an enzyme in just a little bit. Another example of, okay, what you can call proteins, which, okay, chemically will be protein, is going to be as, okay, hormones. Now again, as, okay, hormones are chemical substances, okay, produced primarily as, okay, by your endocrine glands. Okay. Chemical substances, okay, that may, as, okay, facilitate or regulate functions of body tissues and organs. But ladies and gentlemen, a vast majority of your hormones produced by your body are proteins. Only a smaller fraction of hormones produced by your body are steroids. So the vast majority of your enzymes, hormones, chemically, yes, okay, are protein by nature. And what does it mean to be protein in nature? They are made up of a longer or shorter chain of individual building blocks called amino acids. Okay. Here if we say, okay, for instance, such a substance like hemoglobin. Now just here, okay, you see, okay, globin itself, okay, that's a protein. So you can say, okay, without globin, which is a protein, your body would not have been able to, okay, make the molecule called hemoglobin, which is, okay, as you can say, the vital component of your red blood cells. Now, guys, have any of you ever heard the term vitamin? Or have any ever you seen the word vitamin? You can hardly make your way through, yes, okay, any pharmacy or Walmart or Target or whatever without coming across where it says vitamin. Now, does anybody ever know what a vitamin is?
A supplement? It's like a
Oh,
supplement.
okay.
Ooh, shit.
Okay. You said supplement. Okay.
Yeah.
Good. Anybody else?
Elements? Are they elements, right?
No,
Calcium.
not really. No, my DTs actually are going to be molecules.
Oh,
Okay.
then no.
Okay. That's fine. But okay, when you look at your, let's say, okay, the vitamin tablets. Okay. That's okay. You will find elements such as iron. Okay. Vitamins and iron. You may find other elements like, okay, zinc, phosphorus, calcium, etc., etc., along with the vitamins. So that's okay. Those things would be elements, but the vitamins are molecules. Yes. Nobody want to tell me what a vitamin is? Okay, guys. Now let's just break it down. Yes, okay, how the word vitamin came into being. It may be from Vita. Now, Vita here is not the name of a lady. It means okay, it's derived from the word vital. Did that make sense? Which we made yes, okay, says okay, why did that just become yes, okay? What some people will call yes, okay, necessary, or actually yes, okay, the word will become essential. And then the amine. This amine here is mainly as okay from the term that we call amino acids. Amine is okay because amino acids themselves were okay molecules. That's why, my dear, that I said that a vitamin is a molecule. Well, you may have heard the word essential amino acids. Okay, and why do we call them essential? Because the only way for your body to get these amino acids is through your diet. So they are mainly considered to be as okay essential, or has to be as okay essential components of your diet for your body to be able to get them. So it means that's okay, amino acids that your body isn't able to produce by itself. And that's why it's okay. Now, primarily or ideally speaking, my dear, you will need to get that through your diet. The supplement word, well, okay, yes, you say, okay, I can go and you can buy, okay, as a bottle of vitamins or multivitamins. But the supplement word is mainly, it's okay, just that term introduced by the big pharma. Ideally speaking, my dear, is okay, you should eat the food which provides you with these vital amino acids. If that makes sense. So what vitamins are is mainly just okay, what we just can call is okay, it came from the word vital amino acids. But they just shorten it down. Okay. Or in some texts you may come across the word essential amino acids. That's the common term that they may use for vitamins. And why essential? Because you have to get them from an extrinsic source because your body is not able to produce these amino acids by itself. Did you guys get that? Good. So here, yes, okay, vitamins is a form of amino acids, which then builds up or makes up proteins. Okay, guys. Now, please keep in mind, guys, that protein is not a source of energy. Or let's say it's okay, is just smuggle a word in here. Ideally not a source of energy. So guys, if your body needs energy, the primary source was glucose or sugars. Yeah, okay. If your glucose supply was low, it would use fat as a source of energy.
Did you say
No.
produces fat?
No, it will use fat
Use fat.
as a source of energy, right? Okay. But that's okay, even if you assess, okay, run down low on fat, and your body still needs energy, it may, yes, okay, start to break down your muscles and use that as or use the proteins there to become a source of energy. That's why you may see us, okay, if you look at some picture of focus, severe malnourished people, that they actually end up having close to no muscle mass at all. Or it's okay, people who may have starved themselves due to anorexia, that they're just skin and bones, right? Okay. Now, as far, okay, the amount of energy that protein may carry as the amount of calories is going to be the same as that of sugar. So 1 gram of protein is able to produce 4 calories of sugar, of energy. So either has the same calorie value as that of sugar or carbohydrates. Okay. Now, guys, when we look at, okay, yes, the different structure or different types of proteins used in, yes, okay, different ways. For the muscle building, it's going to end with in. Actually, that's okay when we get to, that's okay, skeletal system or muscular system, sorry. You may see it's okay that are going to mean it's okay, just be 2 proteins, myosin and actin. Or what the word or what the ending suffix in here is okay, mean indicates that these are proteins. Likewise, guys, for the hormones, now just an example of a protein hormone is insulin. It's a hormone, but chemically, yes, okay, or if you look at a chemical structure, it is a protein. You can even, as I say, thyroxine. Part of it is going to be, yes, okay, is going to be derived from proteins. When we look at the globin, your hemoglobin, yes, okay, it ends with in. So that is also going to be, yes, okay, indicate that, okay, yes, this is a protein. The thing is going to be a little bit different, yes, okay, if you talk about, yes, okay, the names of enzymes. And guys, just to discuss the enzyme, let me just, yes, okay, bring you back to, yes, okay, the example of what we call lactose. That I mainly says, okay, was a disaccharide. Mainly because, okay, it was chemically, it's okay, made up of glucose and galactose. So these 2 sugar molecules has, okay, being bound together makes what you call lactose, which we mainly says, okay, when this lactose has, okay, was chemically as, okay, broken down. What it will really, or what we will get from it was glucose and galactose. But the question comes is, okay, how is it that this lactose is going to break down? That is going to be because that, okay, yes, it will be acted upon by an enzyme, which chemically, yes, okay, is a protein molecule. Okay. But functionally, yes, okay, that protein molecule is going to be a enzyme. And this enzyme here is, okay, is going to be called lactase. So what you mainly will see that, okay, as any substance that ends with the word ase, A-S-E, mainly as okay makes it an enzyme. Here, this lactase, what is called lactase because it acts upon lactose. Which is pretty much okay, just as okay, the sugar that you find in milk. And maybe okay, due to this action of the lactase upon the lactose, is that it actually is going to be chemically catalyzed into glucose and galactose. Now, have any of you ever heard of what they call lactose intolerance? Now, what happens if somebody is lactose intolerant?
Their body can't digest lactose.
They can't digest lactose, or let's say it's okay, they can't digest milk. Or rather, to be as okay, more correct, they can't digest the sugar in the milk. Okay. Now, the primary reason for that is because that they do not produce the enzyme called lactase. Oh yes, okay, their body is pretty much not equipped with the enzyme to digest the sugar in milk. Did you guys get that? That's
Did you
pretty
say, oh, sorry. I was gonna say, did you say hormones were derived from fat or protein?
they can be both.
Okay.
So some hormones, my dear, are going to be as okay, fat derived or fatty in nature. Things such as estrogen, progesterone, they are derived from fat. So chemically, it's okay. Well, they're still going to be hormones, but we'll call them steroidal hormones. Other hormones are as okay derived from proteins. Your growth hormone, for instance, is a protein hormone. Insulin is a protein hormone. Did you guys get that? Okay. So you may look on so a lot of blood tests, for instance, okay, you may say it's okay, a bigger or longer word that ends with the phrase ace, and ace. And what does that mean? That this substance here, this substance here, this substance here actually is okay, is an enzyme. So yes, okay, a substance that ends with the word or suffix in is a protein. A suffix that ends with this word or substance which name end with the word "-ose" is most likely a sugar or carbohydrate. And a substance which names ends with "-ase" is an enzyme. The enzyme chemically is okay, still are proteins. as far as the chemical structure is concerned, they're still proteins, but chemically speaking, yes, okay, they have a different function. And what is going to be a function of an enzyme is speeding up or helping in the carrying out of a chemical reaction. That's, as I said, breaking down lactose into glucose and galactose requires an enzyme called lactase. So just like this one here, so okay, the body produces an array of enzymes, which all are chemically, they are proteins. But here, it's okay, their function is going to be that they will act as enzymes. Did you guys get that? Now, last but not the least, let's say, okay, the last of our organic compounds. Or molecules are what we can call as, okay, the nucleic acids. Now, guys, these nucleic acids here, is okay, actually are still going to be as, okay, protein molecules or compounds. As far as we talk about as, okay, them being nucleic acids, we mainly as, okay, have two subtypes of nucleic acids. One is going to be as, okay, what we may abbreviate as DNA. Now, you may have heard the abbreviation DNA. Or as, okay, what is it that DNA stands for? The D is going to stand for deoxyribo. The N is going to be as, okay, nucleic, and A is going to be acid. So one kind of, yes, okay, nucleic acid that we will have is going to be what we'll call the deoxyribonucleic acid, or abbreviated as DNA. And this is actually, that's okay, what's going to form is, okay, we can say it's, okay, the genes. The other kind of nucleic acid that we'll have is still going to, yes, okay, be ending up as, okay, the abbreviation is going to be Na, which just stands for nucleic acid. Or which is going to, yes, okay, which is going to be R. And where here is, okay, the word R mainly is, okay, just stands for ribo. Okay. So these are, yes, okay, the two major groups of nucleic acids. Deoxyribonucleic acids and ribonucleic acids. Now the difference between these two is, okay, we will, yes, okay, just talk a bit about them in the next chapter when we talk about the genes. Or that's just, okay, genetic matter. Or what actually is, okay, becomes DNA, which becomes the genetics or genetic matters. But just put it in a way, let's put it this way, dear, is that RNA will become DNA. And when DNA is, okay, mainly is, okay, will make, or we can call it, okay, chromosomes, which become genetic or genes. Now, as far as the DNA is concerned, or RNA is concerned, there's mainly as, okay, only going to be as, okay, 4 different proteins, or let's say as, okay, nucleic acids. So for your DNA and for your RNA is, okay, you may as, okay, just have 4 different amino acids. Now with that said, 3 out of these 4 is going to be as, okay, the same whether we talk about them as RNAs and DNAs. So the common ones that we will have in DNA and RNA is going to be as, okay, what you can call adenine. Guanine. And cytosine. So that's going to be as, okay, where we also will have in the RNA. Adenine, guanine, and cytosine. The ones that are going to be distinct between RNA and DNA is going to be as, okay, that in RNA, we have as, okay, what we call, in DNA, sorry, we have as, okay, what we call thymine. And for DNA or RNA is, okay, is going to be as, okay, what do you call uracil? So even if we talk of, okay, that's a longer or shorter, yes, okay, RNA molecule, it is pretty much what's going to be as, okay, a longer chain made up of this, okay, these 4 nucleic acids here. Or protein elements, sorry. Following one another in a shorter or longer chain. Which means it's, okay, we'll make a DNA molecule. Or an RNA. And the same here. Did you guys get that? Okay, now some of you may be scratching your heads. Okay, how much of this do we need to remember? Okay, dear students, as long as you know what the abbreviation DNA stands for, you should be GOOD. As long as you know what the abbreviation RNA stands for, you should be GOEE or GOOD. So RNA is not a registered nursing assistant or ribonucleic acid. DNA is not doctor and nursing assistant. No, that is going to be deoxyribonucleic acid. Okay, however, you will realize that, okay, the next chapter is that your DNA is mainly, as okay, derived from RNA. So what to begin with was RNA becomes DNA, which becomes your chromosomes, which becomes your genes. Did you guys get that? Any questions? Yes, dear guys. Any questions? Nope. Okay. Then just get something to eat or drink or take a short refreshing break. And I guess I will see you guys back in, should we say 10 minutes? Is that a fair deal? Okay. So we will just talk a bit about okay, metabolism and not really home. Okay. And our next topic is going to be okay, metabolism. Okay, guys. Now, just an honest question, and please answer honestly. When you hear or say the word metabolism, what do you mean? No, don't read it from the book. Before even opening this book, before even it's okay. If I said metabolism on day one, what would you have said?
How well you digest your food, or how well your food is digested when you eat.
Okay. They immediately says, okay, I took a big piece or a big bite of this and broke it down. Now, the initial breakdown, that is going to be as okay, digestion. But what we understood from is, okay, what Asma just said is that, okay, as anything which is further broken down will be metabolism, right? Usually, as okay, when people talk metabolism, that's what they think of, which is not fully incorrect, but that's not the whole truth. Okay, so guys, metabolism is mainly as okay, this is going to be an umbrella term, which mainly as okay will include, or is okay, it says like there's going to be two types of mechanisms that can be referred to as metabolism. Okay, and these are going to be as okay, the complete opposite of one another. So one is going to be as okay what we can call metabolism. And the other one is going to be anabolism. Now, guys, catabolism. This is actually just okay where there is, we can say it's okay breakdown of a molecule or compound. Okay. Just before going on break, or they may not necessarily as okay an accurate example where we can say it's okay that lactose is going to be as okay catabolized to become glucose and galactose. That makes sense? Okay. But generally, it's okay what the word catabolism or B was what people commonly as okay assume that the word metabolism means. For me, it's okay breakdown of any molecule, bigger or smaller, into smaller molecules or compounds. Or we can say, okay, even as okay, things such as inorganic compounds or molecules being broken down into elements will be catabolism. So mainly as okay, the breakdown phase of metabolism is called catabolism. That means okay, just can say that anabolism still is okay. Come under the umbrella of the term metabolism. Is actually going to be as okay, we can say as okay, the buildup of molecules. So where we said that okay, if we took for instance, okay, two elements, one element and another element, and joined them. This junction of these two elements here is okay to form a molecule. Will be as okay what you can call anabolism. Or even if we say it's okay that we took different molecules, but mainly as okay, join them together to yes okay form okay as a more complex molecule or compound will still be yes okay anabolism. Did you guys get that? So just as I said earlier, well, okay, yes, we might have a protein. Clear, okay. Which was made up of, okay, yes, a bigger or longer chain of amino acids. Okay. When this bigger or longer chain of amino acids that makes this protein here is broken up for weak metabolism. And what we get as a result of that was that now these amino acids, yes, okay, are going to be free. Okay. But we may say, yes, okay, this amino acid may join with this one here, which may join with this one here to make a new protein. So when they join, yes, okay, make a new protein, there will be anabolism. There's the breakdown of it, or the first protein was catabolism. So when anything is broken down, that is what we call catabolism. And when anything is put together, will be anabolism. So yes, okay, you're dropping, yes, okay, your favorite crystal ware on the floor, and it breaks into pieces. That's catabolism. You sitting and yes, okay, try to, yes, okay, put those pieces together will be anabolism. Okay. Did you guys get that? So that even happens, yes, okay, with chemicals in the body. You know? Yeah. Okay. Any questions about that? So what most of us primarily as okay thought of as being metabolism actually is catabolism. Now a couple of examples, guys. Now there's going to be a molecule, and we may may refer to it as later on as well. But it's going to be abbreviated as HEP now. Now what the HEP actually is, now this is a molecule, but the question is, what does A stands for? Adenosine. The word T here, the letter T here is mainly stands for tri. And P as in Peter stands for phosphate. Okay. So dear guys, we actually have a molecule known as HEP. Okay. Which, if we, for instance, just want to look at it, is mainly going to be a molecule of adenosine. And what we actually how attached to this adenosine here is going to be 3 molecules of phosphate. That's why we call it HEP, because it has the adenosine to which just 3 molecules of phosphate are attached. Sorry, that was probably the wrong part to start. Okay. Because where does HEP come from? We had carbohydrate. Or the carbohydrate here is which is glucose. And when it interacts where, okay, yes, XYZ number of molecules. What we get from that is 2 molecules is going to be produced, or rather simple molecules. One is going to be carbon dioxide. The other one is going to be water. Okay. And pretty much okay, because what happens is, okay, we can say due to the interaction between carbon dioxide, okay, the carbohydrate and oxygen. But mainly as okay, what will happen is that okay, this carbohydrate molecule here is catalyzed. Or we can say that catabolized. Where okay, that the bonds between the carbons and the hydrogens and the oxygens are broken up. That will be catabolism. What happens as a result of okay, the breakdown of these bonds here is, now just to make a long story short, that's going to just okay release as okay or produce an end molecule packet, which we call ATP, which is going to be as okay the packet of energy. Now this conversion from this to this is a long chemical reaction. We're not going to go into that. That's what they call it, okay, the citric acid cycle. So if you were studying this, okay, biochemistry at some point, it's okay, that would be something to study. But we're not going to. Okay. So from the catabolism of glucose in the presence of oxygen, the end product that we get is going to be ATP. Did you guys get that? What we can mean is that, okay, that breakdown of the glucose molecule is catabolism, where you have hydrogen, carbon, and oxygen released. Where the carbon and hydrogen, oxygen and carbon join to form carbon dioxide. Hydrogen and oxygen join to form water. Okay, but then we also have okay the release of okay sugar. So at the end, pretty much from the breakage of these bonds here is going to be ATP. Okay. Now, guys, what is going to happen to this ATP here? Right, we just look at it as okay as an adenosine molecule with 3 phosphor molecules. That's why it's called adenosine triphosphate. What mainly is going to further happen is, let's say it's okay, this bond between it's okay, the adenosine and one of the phosphates is also going to be it's okay catabolized. So yes, okay, we'll have catabolism of it, of this ADC or ATP, sorry. And what that made is okay, this will lead to is ADP. The guy here is okay, the A is still adenosine. The P is still phosphate. But it's okay, what remains is C here that okay, we only have 2 phosphate molecules attached to the ATP. attached to the adenosine. So that's why it's okay, that becomes adenosine diphosphate. Okay, and pretty much okay by the catabolism of this bond here is okay. Is okay, you will have one free phosphate, but it's okay. The breakdown of this bond here is going to release energy. Okay. Now, what mainly is okay, normally will happen then is that this ADP is okay. Maybe we get back into this chain here and produce new HEP. But it may still happen that, okay, this ADP or adenosine diphosphate here can be further catabolized. Okay, and what do you have? Okay, if that is going to be the case, what do we have then? For me, it's okay, just end up with, okay, what we'll call adenosine M. Okay, what the M stands for here is going to be phosphate. And what the M is stand for here is going to be mono. Because, okay, even if it lost, it's okay, its second phosphate molecule, or atom, sorry. You will only have, it's okay, the adenosine carrying one phosphate. So whether it is adenosine diphosphate that may is okay enter this reaction here is okay, gets anabolized because it's okay that ADP is going to just okay receive a phosphate molecule and then become HEP. We just can okay enter this reaction here again, or get catalyzed again. Okay, but this here is going to be as okay an example of anabolism. Where your ADP is being joined with a free phosphor, or phosphate, sorry, just to become HEP, which now is okay as the same adenosine with the three phosphates. Okay. So long story short, this is pretty much okay how glucose becomes just okay your primary source of energy. Right. So that's okay, all the glucose, or that's okay, substances that you eat that contain glucose or sugars, or bigger molecules of sugars, which might have been broken down and release sugar or glucose. That's okay, is broken down, that's okay, that will be catabolism. And you that final packaging of okay a source of energy known as HEP or adenosine triphosphate further gets catabolized or is okay broken down because you cut off one phosphate, it releases. So the breakage of that bond actually is okay cause release of energy that your body will be using. as source of energy. Any questions? So whenever you have,
So
okay,
just to make sure sorry. I just want to make sure I'm understanding correctly that ATP breaks down into ADP, and ADP can be further broken down into AMP, but then the process starts all over again and it goes back to being
very much. Yeah.
ATP. Okay.
It's okay. Let me put it this way, and that's why I said it's pretty rare. It's pretty rarely happened that the adenosine diphosphate becomes adenosine monophosphate, but never say never. Okay, what it may like this, okay, will be that, okay, as ATP becomes ADP. Now that was catabolism, where that ADP may as, okay, joins the cycle and becomes ATP. But ADP, or adenosine diphosphate, becoming ATP, or adenosine triphosphate, will be, yes, okay, so it's okay, a small example of anabolism. Did that make sense?
Yeah, thank you.
Or even, yes, okay, we said we had multiple proteins. Now the breakdown of those proteins into, yes, okay, individual amino acids, which are now free birds. That breakdown is catabolism. Did that make sense?
Yeah, thank you.
Good. Now, in the initial proteins, that's okay, what makes them the proteins that they were mainly because of the sequence in which those amino acids were joined end to end, always, okay, in a bigger or longer chain. But some of those proteins from that broken down, or some of the amino acids from that broken down protein may not join together. And that joining of those amino acids is what you will call anabolism. And what's going to be the result of that? You just says, okay, produce a new protein. Did that make sense?
Yeah.
So simply break down, catabolism, rebuilding, or else, okay, putting things together, in this case, is going to be anabolism. Did you guys get that? Okay. Likewise, lactose broken down. Now, when you break it down, that's going to be anabolism. Oh, sorry, catabolism. Okay. What was necessary for the breakdown of lactose? Lactase. The enzyme to break down lactose. Clear? Okay. Kita. Talk was based on what on the corner. Bye. Any questions, guys? Okay. Good. Now, homeostatic mechanisms and maintain as okay to maintain an appropriate internal environment. The only thing that you guys need to know about this, don't worry about the positive feedback mechanisms and negative feedback mechanisms, what those are. The main thing that you guys need to remember is what is homeostasis, not hematostasis. Hematostasis is something different. We'll talk about that in blood. What is homeostasis? After that. Let me see you. So what is homeostasis? The ideal internal environment of the body. Clear? Okay. What did we need to maintain that? Harmony between all the organs within a body system and harmony between all your body systems. Did you guys get that? Now, just a short example, guys. When you run, or when you run, or let's say it's okay, workout or whatsoever, what happens? Okay, why would you run on a treadmill? Let's say it's okay, you say, I want to work out.
You burn calories.
You burn calories. Now, my dear, where are those calories going to come from?
Carbohydrates. Is that what you?
Exactly.
Carbohydrates. Yeah.
Good. So you can say, it's okay, the faster and faster and faster you run, you burn more and more calories, which mainly mean that you break down or you catabolize more sugar, right?
Mm-hmm.
Clear? Did that make sense? Okay, now what we just said was that the more sugar that you break down, okay, as one thing that's going to be produced at the other end is going to be carbon dioxide. Now, what you guys will realize in a later stage is that, okay, carbon dioxide is going to be, as okay, we can say it's like a waste gas. Now, how do your body get rid of that? You start breathing faster. Clear? Okay. At the other end, now, since you breathe faster, it's okay, you'll get more carbon dioxide in a minute or so and so. That compared to, it's okay, what you are doing now. Because right now, it's okay, you may be just breathing 16 to 20 times a minute. That breathing rate is okay, may increase as you work out more and more and more. Because you produce more carbon dioxide. And that's something that, okay, your brain mainly is okay, regulates. But at the other end, you also say, well, okay, when I stepped on that treadmill, at that point, yes, okay, my heart was beating 62 beats a minute. Now it's 110 beats per minute. Or let's say it's okay, 130 beats per minute. And why in the hell is that? Mainly it's okay to just increase the blood supply to your body. Helping you, yes, okay, helping those cells to get rid of that carbon dioxide that they produced as they were breaking down more and more glucose. But the other end also is okay, going to be supplying more oxygen to your cells so that they will be able to, yes, okay, break down that glucose to make it a source of energy that you're needing as you are running. So the reason that you breathe faster is mainly as, okay, your tissue will need more oxygen because they produce more carbon dioxide. And we still need more oxygen to just, okay, break down more sugar or glucose to fulfill the energy requirements. So that's all, that's okay. And all that is, so you can say it's okay, you can say it's okay, maintain as, okay, the chemical homeostasis. Now at the other end, okay, now yes, okay, you burn down more energy, but your body actually is, okay, produces more energy in form of heat. So what actually also happens is that your body temperature is, okay, may increase. Now, as a result, to cause that, so to ensure that, okay, you don't catch fire, probably not, okay, is, okay, your body said, well, okay, the temperature of the body is mainly just, okay, increasing. Now, how do we cool it down? And that's when you sweat. So that sweat is mainly as, okay, just again, it's okay, a homeostatic mechanism to ensure, it's okay, not trying to, but actually, so you're going to cool down your body. And after that heavy workout, where you burn a ton of calories, you had sweated profusely because, well, that's what I'm thinking, increased amount of this, okay, heat energy be produced by your body as a result of the exercise. You lost some fluid. What is going to be your next signal? Thirst. So that's why you say, okay, let me get hold of, okay, as that water bottle, and okay, let's drink it. So all this was mainly as, okay, you can say it's, okay, homeostasis. Chemically, physically, mechanically, theoretically, practically, whatsoever. All those things, yes, okay, ideally, it's okay, walk hand in hand to maintain that normal internal environment of your body called homeostasis. You may even feel it's okay, a little bit low on energy, so that's why it's okay, regular water may not do it. So you say, okay, let me just get some Gatorade or Powerade. And what do you have in that? Some sugar and some salts. Prime, yes, okay, sodium, because that's okay, one of the salt that, okay, as will be with the fluid that, yes, okay, evacuate, yes, okay, leaves your body in form of sweat, contain sodium. Yeah. Any questions, guys? So the only thing that you guys will need to know is, okay, what do we mean by homeostasis? Is just, yes, okay, the maintenance of focus and ideal internal environment of the body. Okay, just like it's okay in a fever. Just remember the last time you had a fever. One thing that may happen is sweat. Just your body's way of trying to just, okay, cool down the body. But when that fever breaks, and your body now has cooled down, what may happen? You may start to shiver or have chills. And that's just your body's response to try to bring up the body temperature to normal. I just think, yes, okay, God, you walked out, you didn't realize there was that chilly or cold outside. So I'd be able to just, okay, go and fetch the mail from the mailbox down the driveway without, okay, as wearing, okay, as a coat or a hoodie or something. It was colder than you thought. And when you come back, it was cold. Well, that shivering, that is pretty much, okay, it's just your body's way of trying to warm up your body to bring it back to that relatively, yes, okay, normal range of temperature. So a lot of things are pretty much, okay, everything here is your body's response to try to bring it back to the normal. And that's what we call homeostasis. Now, is there anybody who wants to say anything now? Nope. Good. Then go and maintain homeostasis. Get some glucose. Let some whatevers. And I guess I will see you guys in, should we say 40 minutes from now? Good. So 12:45-ish. Enjoy your break. And okay, so you said ATP. Okay.
Right.
So,
ATP.
yeah. So it starts off with ATP. Now, what did we say that ATP was? It's made as, okay, just a molecule. Okay. What made it? Adenosine. Well, let's say it's okay if this here is the adenosine, adenosine. When we say ATP, it's going to have 3 phosphate molecules. Okay. So the reason that it's called triphosphate is because that you have 1, 2, 3 phosphate molecules bound or attached to this adenosine. Did that make sense? Yeah, okay. Now what we just said was that, okay, yes, this is going to get catalyzed. Mainly as, okay, by as, okay, releasing this phosphate here. So what we end up with is, well, okay, you still have your adenosine. But what mainly going to be left of this molecule here after this, okay, releasing this phosphate here is just 2 phosphate molecules. So mainly it's okay because we are just left with 1, 2 phosphate molecules. That's why we can say it's okay that that will be diphosphate. Okay, where you can mean says, okay, what happened to the 3rd phosphate is, okay, that just breaks loose. And pretty much, okay, by it breaking loose, that's okay, what's going to happen here is that there is okay will be release of energy. Because what actually is okay, hold the phosphate here and these two other ones here to the adenosine is mainly as okay a bond, which is energy. Did that make sense? Okay. Okay. So from ATP, losing a phosphate, mainly because the bond is broken and release energy, you end up with adenosine having two phosphate atoms. So that becomes ADP, or adenosine diphosphate. Did you guys get that? Okay. But what we mainly can say that ATP is mainly as okay, just the packaging unit that stores the energy that your body cells will use. Okay. Where this is produced, well, okay, we will talk more of that as okay in the next chapter. Okay. Any questions? Did I answer your question, or is it still floating on top of your head? Okay, guys. Now, this following thing here is okay. Maybe we can say it's okay. Just what you guys may remember a bit of from your medical terminology. Okay, especially it's okay of, we can say it's okay dividing the body into different parts. But before getting into that discussion, please keep in mind, guys, that there's going to be as okay something that we call the anatomical position. Okay. And why do we call it okay? Why do we talk? Oh, yes, okay. Why is it that we use a term of anatomical position? Primarily because, guys, any anatomy that we will be discussing, or whenever it's okay, we discuss the anatomy of the body, you have to mainly it's okay, just assume that the body is placed in this standard fixed position that is going to be named as the anatomical position. Is that clear? Okay. You may find, okay, as a person lying down on the side. But even in that case, that's okay. If you want, just okay, describe his or her anatomy. You still have to do it considering that, okay, as his or her body was in the anatomical position. Okay. You may see somebody as okay being hanging upside down. But even then, if you still want to discuss his or her anatomy, you still will have to do so by as okay considering his or her body being in the anatomical position. Did you guys get that? So right now, none of you are in the anatomical position. Even not me. So what's going to be the anatomical position? Now you can break it down. Oh, that's okay. But first is, that's okay, standing straight up. So first of all, it's okay, what would we need? That a person is standing straight up. Yeah, okay. We can even say as okay, looking straight ahead. Okay. So even if somebody is okay was standing straight up, but looking to one side or to the other side, or up like this or down, he or she would not be considered to be in the anatomical position. Did that make sense? What's next? Oh, okay, usually it's okay. My teacher used to put this one here as number 2. So standing straight up, looking straight ahead. Next is the arms hanging down on the sides. So again, saying yes, okay, if I was standing straight up, still looking straight, but if I held my arms like this, or like this, or like this, or like this, that would not be me standing in the anatomical position. So to be in the anatomical position, yes, okay, you were standing straight up, looking straight ahead, and your arms would be hanging down the sides. So you can't have it crossed across your chest like this, right? Yep. Hanging straight down. And here comes the last. Oopsie moopsie. Sorry, guys. And palms facing forward. So if you look here, on both hands, the palm should be facing forward. And that may cause that this is okay becomes your thumb, index finger, middle finger, sorry, ring finger, and pinky. And so like it's thumb, index finger, middle finger, ring finger, and pinky. So that is your anatomical position. So standing straight up, looking straight ahead, arms hanging down the sides, and the palms are facing forward, like this. But of course, that's okay, hanging down the side, okay. But this will mainly mean, right now, my palms are facing forward. Did you guys get that? That's your anatomical position. So that's okay. It's probably
Is there a name for when your hands are face forward? I forget what there's a name for it. Like the anatomical of having your hands forward.
no, I mean it's okay. Well, name for it. That's pretty much okay how they just define it.
Okay, thank you.
Okay. So doesn't really matter. It's okay whether you are studying Gray's anatomy, Blue's anatomy, Yellow's anatomy. Probably is okay. The first thing that you will see, no matter is okay, how short or big a book of anatomy. First thing that you need to understand is the anatomical position, because everything that's going to be discussed in anatomy is, well, okay, you have to be able to consider the body being in the anatomical position. Or hey guys, sorry. Or if you just look here. Okay. Sorry. Okay. This is mainly as okay. Well, I guess it's okay, an anterior view of somebody as okay standing in the anatomical position. Or it's okay if you look at his back here. Okay, so standing straight up, looking straight ahead, arms hanging down the sides with his palms facing forward. Did you guys get that? Well, if you just remember it, that's okay. In the way that I just told you, that's okay. Well, that's how. So you can actually break it down standing straight up, looking straight ahead, arms hanging down the side, palms facing forward. So this is pretty much okay, the first thing that okay as we learned on day one in anatomy. Now, okay, guys. Now we have different regions. Now let me just ask you guys a question. Do you guys still want me to go over what is sagittal plane, transverse plane, frontal plane, or coronal plane? Are you guys good on those?
I'm good on
I
it.
Sagittal,
think I'm good on those as well.
transverse, and coronal or frontal. Okay, Susan is good with those. Anybody who say, okay, I still don't get it. Guys, please, it doesn't hurt to say that I didn't get it. You didn't get it, you didn't get it first time. That's fine. If no, I have no problem. I can proceed. So everybody's clear about the planes?
Mm-hmm.
Okay. Good. Any questions about your cavities? anterior, posterior cavities. What structures did we have in the posterior cavities? What structures did we have in the anterior cavities? So let's put it this way. What cavities came out of the anterior cavity? What cavities came out of the posterior cavity? Cranial and spinal were from the posterior cavity. Thoracic and abdominopelvic from the anterior cavity. Okay. Between your cranial cavity and spinal cavity, that's okay. They were connected together through a opening at the base of your skull known as foramen magnum. Where foramen is just a word for opening. Magnum just because okay, it's a hell of an opening. So the word magnum just means big O. Clear? Okay. Your thoracic cavity and abdominal pelvic cavity, two subcavities of your anterior cavity, right? Which are separated by a sheet of muscle known as Mr. Diaphragm. Okay. Now, what did we have in the thoracic cavity? Two pleural cavities, and in between those two pleural cavities, which holds the lungs, was the mediastinal cavity. Clear? Okay. So in between the two pleural cavities, the mediastinal cavity. Whereas lower to that was the abdominal pelvic cavity. Okay. But there was no SOK. There was no physical SOK structure that separated the abdominal from the pelvic cavity. Or we can mean it's okay wherever falls within, or we can call the pelvis, which is going to be made up of your hip bone and down here. So okay, here the last remaining part of the spine, which is the sacrum, is going to be okay, your pelvis or pelvic cavity. Did you guys get that? Okay. So guys, if you just look on page, well, okay, in my case, it's okay, it's page 14, or a table that says table 1.3 or 1-3. Do you find that? Terms related to yes, okay, indicate specific body regions and structures. Okay. Now, guys, let's just look at the first one. Abdominal, abdomen. And what would that be? Area or region between the thoracic cavity and the pelvic cavity, right? Or pelvis. Arm. Now technically, it's okay from shoulder to fingertip. Clear? Okay. Anatomically, guys. Now, when we say anatomy, let's just look at Mr. OG here. If the anatomy is okay, we say arm. Okay, it can be the whole thing. Okay. Yes, okay. It's going to be this. Now, this is what we actually is okay, will refer to as the upper arm. And a technical word for upper arm is going to be brachii. Whereas this part here is what we technically is okay will refer to as the forearm. Now, which we actually is okay also we call cubital. And that's why you mean it's okay between forearm and upper arm. You may see this region here, which is going to be antecubital. Or even here. Now, for a lot of lay people, we may consider this thing here as okay as hand and then fingers. But anatomically, don't be so quick on that. Because this here, or even as okay, we circle it here. That is what you can call, in plain English, as okay, you will call a wrist. Technically, as okay, that's going to be as okay, what we can call the carpus. Or we may as okay, just use the word carpal, which is going to be as okay, a term that in technical as okay will mean wrist. Okay. Now, guys. Now, whether it's this or whether it is this, both can commonly as okay be referred to as, yes, that's okay, the hand. But this is going to be as okay, where we mean you can say it's okay that it's okay knowing your anatomical position. Is going to be important. So when we say that, okay, as hand facing forward, sorry, our palms facing forward, that will mainly mean that, okay, as this side of the hand your palm actually is going to be, or we can call it, okay, the palmar surface of your hand. Whereas if you still look at the hand, but this back side of the surface, which is not the palm, but the back side of the surface, that is going to be as okay called the dorsal surface. Or we can even say as okay the dorsum of the hand. Okay, so right now, this is the palmar surface of my hand. Clear? This is my, or these are my palms. This, yes, okay, being the back of my hand, but actually that's okay, will be the dorsum of my hand. Where the word dorsum, now why do we call it a dorsum of the hand? Because that's going to be coming from, yes, okay, upper saying, yes, okay, dorsal, which is just another word for posterior or back. Okay, when we said anterior, we could also call it ventral. Posterior could also be called dorsal. So mainly because this surface here, okay, faces backwards. When I'm standing, yes, okay, with my palms facing forward. That's why this is called the dorsum of the hand. Did you guys get that? Any questions?
Yeah, I have one question. I'm sorry. It's something that was said about the upper arm and the forearm.
Mhm.
So can those be both viewed as anterior and posterior view?
Now, when you say anterior view, what does that mean?
Anterior is in the front.
Yeah. So
And
when
then
you're looking at somebody who's standing facing you, right?
forward, yes.
Okay. When you say posterior, it's going to be as okay, you standing behind him.
Yes.
Okay. In both cases, this whole thing here. You can say it's okay from shoulder to elbow is going to be upper arm.
Maybe.
Whereas from elbow to wrist is going to be a forearm. Whether you talk about the front or the back.
Okay. All right. Thank you.
So both anterior and posterior, yes. This whole thing here, upper arm, this forearm.
Okay.
Okay. So whether you look at the anterior or posterior, okay. So you can say it's okay, this, or even yes, okay. Both of these, yes, okay, would be upper arm, both this and this would be forearm. Okay, but you can say as okay here, anterior of the forearm, posterior of the forearm. Okay, anterior of the upper arm, posterior of the upper arm. But pretty much anatomically, that's okay. This thing here is called the upper arm and forearm. Did you guys get that? No, okay. So What we mainly as okay may see as okay, let's see, the next one will be auxiliary. Very much okay as this area here. Okay. Are you in as okay if he as okay was it's okay. Abducted. Abducted as okay his upper arm. So as okay, the region that you will see as okay underneath the upper arm, yeah, is going to be as okay what you can call the axilla or armpit. We can say cephalic. Now usually it's okay when we go cephalic, that's mainly as okay a term that as okay mainly will be used as okay describe relation of structure here to here, here to here, here to here. And it's okay what you as a whole is okay can call the torso. So something is okay, we say that A and B. That says, okay, you have two structures whose relationship you want to specify. You can say that, okay, as A is cephalic to B. Did that make sense? Because A is more closer to the head than B. The opposite of cephalic would have been pelvic. If you want to compare A to B, you can say, okay, B is pelvic to A, position-wise. Okay. As I say, it's okay, the word cephalic can also be as okay, we can even use okay, use the word superior. We could also as okay, use the word supra. Okay. And we can even as okay, use the word cranial. Because okay, more towards the cranium or skull. Whereas okay, as when you go to down here, it's okay in terms of the torso, you can say it's okay. It becomes pelvic. Meaning it's okay due to the pelvis. They may even as okay use the word caudal. Okay. We can even say, okay, that says, okay, inferior, which is the opposite of superior. Or we can even say, okay, infra. Did you guys get that? Harper, we already did. Celiac now, not actually as okay, abdomen. What the word celiac actually means, guys, is belly. Okay. But just okay. Later in, as okay, towards the end of our module here, or it's okay, E&P, we will talk about a little structure which is going to be as okay called, I'll go under the number, a name, celiac. Cervical in anatomy is okay. This is going to be as okay the cervical area. Costal. Now our L here is pertaining to. Okay, but just keep in mind here, so okay, here the word is not going to be cost. Actually, it's going to be costa. So the word costa is mean that's okay, what you mean that's okay, we'll just use yes, okay, refer to the rips. So you say it's okay. One rib. Okay. And it's going to be it's okay. One costa. Okay. Now guys, we can just say it's okay, we just have a rib about this rib here. Not on the other side. Okay. Let's just say that okay, this here is okay, was the fifth rib. Which means okay, we'll just make this rib here is okay being the fourth rib. Now we actually are going to have is okay this. Let's just let's use this color. This space here in between two ribs. Now since it's a space, it will be called a space. But this space here is going to have a name, and that's going to be very straightforward because it is going to be inter, which means in between. And where is it that this space falls? It falls in between two ribs. So intercostal space. Did you guys get that? So if you say it's okay that we have a rib above and a rib below, the space in between those two ribs will be referred to as a intercostal space. A rib above and a rib below. And the space in between those two ribs will be a intercostal space. Okay. An intercostal space is not going to be as okay, you have four rib on the right side and four rib on the left side. The space between those two ribs will not be considered an intercostal space. It gotta be a rib above and a rib below. Okay. So that will become a intercostal space. Those of you who are CVT students will be dealing with a lot of intercostal spaces. Because in some cases, okay, where you will start is okay, scanning the heart, you will have to use those intercostal spaces to scan through. Okay, so making windows. Not windows for your computer. Okay, leave that to Bill Gates and his technical stuff. You guys know where they got the work or what the word cost actually means? It meant something else before we use it for the word rip.
The middle?
Nope. Good guess. But it's not middle. No idea?
Cover?
Horizon. So that's what the word Costa meant. Now, have you guys heard of a country called Costa Rica? Now, what does Rica mean?
Like rich, maybe?
Rich.
It's
So
funny because
where is America? It is rich aim. Oh, who is Amy? Okay. So yes, okay. Rich horizon. Okay. So good. Cervical costal. Okay. Ribs. Cranial skull. So guys, this is your cranium. Yeah, okay. This will be your cranium. Not all this. This will be cranial facial. So this become facial. And this become cranial. Clear? Cubital. Now elbow or forearm. Okay, now usually that's okay when you go and yes, okay, gets, this is getting big. Okay. Get your blood drawn. This diamond shaped area here. That's what they call the antecubital fossa. Now why fossa? Mainly because it's a slight dip. So the word fossa mainly will refer to as okay, any structure that okay has a slight dip. Cutaneous is there's going to be as okay skin. We'll talk more of that in our, or just a fancy word for skin. Femoral thigh. Okay, and it's mainly as okay. Oops, it's mainly going to be referred to as being femoral because, and or vice versa, because your thigh bone was called the femur. But again, it's okay whether you look at it in the front or the back. This area here is okay, is going to be as okay the femoral region. Okay. Whereas, okay, as if we look at the back side, this and this. All this is okay, is going to be as okay the back side of the what will become the pelvic cavity, but this is going to be as okay what we'll call the gluteal. Okay, so pretty much okay as the buttocks, that's going to be the gluteal. Okay. We already said forearm. Oh, this is the forearm. Whether you look at it on the front or at the back, will be your forearm. Groin. No, ideally it's okay, you will only see the groin in the front. This area here. That's what you can call the groin. Actually, it's okay, the groin is technically it's okay going to be known as the inguinal or the inguinal? Did you guys get that? So posterior, yes, okay, of your pelvic cavity is going to be, yes, okay, the gluteal region, which is your buttocks. Anteriorly is going to be, yes, okay, the groin, or what you can, yes, okay, what technically we're known as the inguinal leg. Pretty much okay, yes. All this here is okay, will be your leg. Lumbar. Especially it's okay when we talk your lumbar vertebra. Mammary is okay, not in this case is okay, but the chest. This area could also is okay be referred to as thorax. We may actually also, okay, sorry, it's getting a little cloudy here, so let me just. Refer to as okay to this area like this. Or even here is okay like this. Is going to be as okay. All the pectoris. So pectoris is mainly as okay, just another name for the chest. But guys, when we say pectoris, it's going to be this part here, not the back. Okay. Now just looking at the skull or cranium. Well, okay, this part of the cranium here is going to be frontal. Whereas, okay, it's the back of your cranium or skull is going to be as okay, what we call is okay, the occipital. Yeah. Okay. I think I already is okay defined palmar versus dorsal of hand. Patellar. And not really as okay your knee, but we can say it's okay the anterior side of the knee. Is what can be referred to as patellar. Mainly because that's okay what we in English may call the kneecap is the patella. Clear? Okay, so pretty much okay from that, that's why you call patellar. So what do you call the back of the knee? Which is actually the word that actually is okay, will mean knee. Or this part here. The back side of the knee or posterior side of the knee is going to be the popliteal. So anterior of the knee, patellar, the back of the knee, popliteal. And actually, it's okay. If you look here, it's okay. You're going to have okay, dip or depressed. So that's what that's okay. This area can also be referred to as okay, the popliteal fossa. Yeah, okay. Paddle. Maybe it's okay from the word pad, which means foot. Paddle, yes, okay, just pertaining to foot. Did you guys get that? Now let's just get to the foot and foot. All that's okay, not that clearly visible here. But we can mean it's just okay, all this region here is what we can call tarsal, which mainly is okay, is just a technical word for ankle. Okay. Good. Now, with that said, guys, just look here. Because this surface of your foot this is actually just okay going to be as okay what we call the dorsum of the foot. Okay. Whereas the surface that you're standing on, now in plain English, that's okay, we call that the sole. But the sole, that's okay, the word for the sole of your foot is going to be plantar. Did you guys get that? And some of you may be scratching your heads and say, but Mike, didn't the dorsum, yes, okay, means behind or back? Just like we say, it's okay, dorsum of the hand. Now, this is where your embryology comes into the game. Or let's just put it this way. If you go and back to times and think of, okay, as when, if they thought, okay, as we might have been primates, or it's okay, descended from the apes, or even as, okay, if you look at your palm of your hands versus the soles. Now, if you, for instance, okay, were to walk on all four, this and the soles. or just yes, okay. God forbid, it's okay, you're climbing a wall. How will you grasp onto the wall? With your hands. Like this, right? And likewise, okay, which part of your foot would you use? The sole. So I mean, this is okay, P for palmar, P for plantar. And that has become dorsum and dorsum. All this, okay, you look down at your feet and say, well, okay, this part that we call the dorsum of the foot is not facing backwards. Okay. But just compare just, okay, palm of your hands and soles of your feet, which is plantar. Dorsum of your hand, equivalent is okay, dorsum of your feet. But when you look down and if you're able to see your feet, that's the dorsum of your feet. Thoracic, chest. I mean, it's okay when we say it's okay, thoracic cavity, thoracic vertebrae, things like that. And last is it's okay, umbilical, known as belly button. Okay. Or as okay, the word is umbilicus. Umbilical just becomes pertaining to the umbilicus. And did you guys know that the umbilicus is the center part of your body? Okay. That's good. Good, guys. Any questions about anterior versus posterior?
Will this be on the quiz that we need to know the specific body regions?
Yes and no.
Okay.
Whether it's on the quiz or not, yeah, it's probably, let me put this, it's probably going to be close to criminal not to understand it. So I think it's okay, a lot of regions, are not really regions, but it's okay, a lot of things mainly as okay are named after as okay the name that they go under. Okay. So that's okay. In regular English, you will say thigh. Thigh is in regular English, but it's okay for your anatomy, it's going to be femoral. Clear? Okay. In regular English, we say wrist. In medical term, we call it carpal. Or carpus. Carpal just becomes pertaining to your wrist. Just think of carpal tunnel syndrome. That's an easy way. Okay, you may not have heard the word carpus or carpal, but you would know of carpal tunnel syndrome, or at least I've heard of it. Okay, then you go tarsal, ankle. Okay. Arm, but it's okay. We actually is okay. Anatomically, it's okay. Then divide that into subparts. Upper arm, forearm. This is all wrist. Many people is okay. Say, oh, isn't this my wrist? No. Anatomically, this is your wrist. And then you just have your hands, and then it's okay, your fingers. We could say cranial. No, it's okay. This was just frontal. Mainly because, okay, the big main bone is okay. That forms as, okay, what you call your forehead is the frontal bone. Back of your skull, occipital. Al mainly is okay, just pertaining to, because it's going to be, okay, a bone called occipitus. Okay. Usually it's okay, we don't use the word occipitus. We may just, okay, let's say it's okay, the occipital bone. Clear? Okay. But then you, it's okay, we'll say it's okay, temporal. You may even say it's okay, parietal. So, okay. Knee, front of the knee, patella. That back side of your knee more correctly, popliteal. But if you want to talk about it's okay, the knee as a structure, it most likely is okay, or most commonly is okay, what we refer to as popliteal. Because poplitea is a more accurate word for your knee. Did you guys get that? So, Nikki, don't worry, it will come. Okay? Slowly and gradually, it's okay, it will come to you. So, but because especially it's okay when we go and start talking about it's okay blood vessels, we will say it's okay, what are the blood vessels in the upper arm? Well, that will be this part. What will be the blood vessels in the forearm? Be this part. And then you have to understand, okay, lateral, medial, things like that. Right. So lateral will be this way, medial towards the center. Superior cephalic cranial, inferior pelvic, sorry, and okay, yes, pelvic and or caudal. Okay, for your limbs or extremities, whether that's arms and legs, distal, the proximal, and then we just go distal. Okay, so those are mainly as okay, two terms, ideally as okay, used for your extremities. Good. Any questions about your cavities? Okay, so guys, tomorrow is okay, what we will be doing is first dividing is okay, our abdominal pelvic cavities into 4 regions. And just roughly speak is okay, what structures or organs falls into those 4 regions. And then we will divide our body or abdominal pelvic cavity into 9 regions. And just briefly summarize what structures fall into those 9 regions. And that will be the end of your first chapter. Any last word of wisdom? Good. Then enjoy the bad weather today. And I guess I'll see you guys tomorrow. Oh, what is it like where you are? Nice.
Raining.
It's the same.
Okay,
Bad.
raining too. Bad. Okay,
Yeah.
good. Bad, raining, and wet. Okay, guys. Now stay blessed, stay safe, and check here. Okay, guys.
Thank
Thank
you.
you. Have a
You,
good day.
bye.
Bye bye, dear.
Bye.